finally, in part C, we're going to do a hypothesis test. They say it is thought that on average, students have lower GPAs in the first year than the second year. Do we think this claim is justified by the data? So before we even look up any data or do any math, we're going to say, what is our null hypothesis? Well, our null hypothesis is that GPA in year 1 equals GPA in year 2. So now they're making a claim. Students have lower GPAs in the first year than in the second year. So we're saying the alternative hypothesis is that the first year GPA is less than, that should be a 1, the first year GPA is less than the second year GPA. So we'll just write that in. Now, there's an important issue here, namely that this is a situation where we'll do a paired test. And why are we doing a paired test instead of a two-sample test? Well, because if this is year 1 and this is year 2, and this is student 1, student 2, all the way down to student 100, right? This depends on this. This depends on this, and so on. But the individual students we're assuming don't have any effect on each other. So I don't have two independent samples. That's why I want to use a paired test. So we'll go back up to the top, right? The average in the first year is 2.5, and the average in the second year is 2.65. And what we care about now is the SD of the difference. These guys, not important because they're not two independent samples. That was useful for our regression. But this right here, this 0.39, is the guy we want. So we want to compute the SE. So the SE for the difference is the SD for the difference divided by the square root of 100. So this is 0.39 divided by 10. So that's 0.039. That's the SE for the difference. And now, when we construct our hypothesis test, we do observed minus so the expected difference is 0, and so what is the observed difference? The observed difference is 2.65 minus 2.5, and then we don't expect nothing else. If the null hypothesis were true, we wouldn't see any change. Divided by the SE of the difference, so the SE of the difference, 0.039. So if we do that, we get 3.85. And this is big. The p-value is very small, so you can just look this up on the table. P-value small. So what does that mean? It means we reject. It means we reject the claim that they have the same GPA the first and the second year, and this provides evidence that the GPA does indeed go up after the first year. Note, and again, I want to stress this point, we do not just do a regular two-sample test. We have to use the SE of the difference, and that makes it a paired test.